In the grand scheme of the universe, not all stars just quietly fade away. Nope. Some of them, the real cosmic heavyweights, go out with a bang so unbelievably huge it can outshine entire galaxies. They end their lives in what's called a supernova, and it's one of the most violent events in the cosmos.
And that, of course, brings us to a pretty unsettling question. I mean, we live in a pretty busy cosmic neighborhood. So what would happen if one of our neighbors suddenly decided to explode? Could an event happening light years away from us actually spell the end of life on Earth? Well, let's get into it.
So, what do we even mean by a near-Earth supernova? First off, don't worry about our own sun. It's way too small and stable to go out like this. We're talking about its giant, unstable neighbors, massive stars that are basically ticking time bombs. The real question is, are any of them close enough for us to worry about?
Okay, so who are the main suspects in our cosmic lineup? Astronomers actually have a watch list, and there are a few names on it that are, well, particularly interesting.
Here's a little rogues gallery of some of the massive stars hanging out in our corner of the galaxy. You can see big names like Betelgeuse and Antares. Both of them are in their final red supergiant phase. This table shows you their distance, and, by the way, a parsec is about 3.26 light-years, and how much more massive they are than our own sun. But for right now, we're going to focus on two especially notorious suspects.
So our first suspect is an absolute monster of a star, Eta Carinae. What's so wild about this one is just how extreme it is. It's a super rare type of star, weighing in at around 120 times the mass of our sun. That puts it right up against the theoretical limit for how big a star can even get.
And it's not just big, it's incredibly unstable. You see, back in the 1800s, it had this massive temper tantrum that astronomers call the Great Eruption. For a little while, it became the second brightest star in the entire sky, all while it was blasting off material equal to 2 or 3 of our suns into space. So yeah, this star has a history of violent outbursts. Now for our second suspect, and this is one you've probably heard of, Betelgeuse. It's that famous red star that makes up the shoulder of the constellation Orion. It's a red supergiant that's getting very close to the end of its life, and it is gigantic. I mean, just imagine this. If you swapped our sun out for Betelgeuse, its surface would stretch all the way out past the orbit of Jupiter. It's huge.
Okay, so we've got our suspects. But how can an explosion that's so mind-bogglingly far away actually do any damage here on Earth? It's not like a shockwave or heat is going to reach us. The real danger is a lot more subtle and a lot more sinister.
The primary way it could get us is through this three-step process. First, an intense flash of gamma rays, the most energetic kind of light, slams into our upper atmosphere. Then, that radiation kicks off a nasty chemical reaction, creating a bunch of molecules that act like little Pac-Men, just gobbling up our planet's protective ozone layer. The end result? Earth's natural sunscreen gets completely shredded.
And that would be very, very bad. The ozone layer is this fragile shield that blocks the most dangerous kind of ultraviolet radiation from the sun, UVB. Without it, life on the surface would be blasted. This would be especially catastrophic for things like phytoplankton in the oceans. The tiny organisms that form the absolute base of the entire marine food web.
But the gamma rays might not be the only problem. What's really fascinating is a newer theory that suggests the danger might not just be from some invisible radiation, but from the actual visible light of the explosion itself. It turns out some of these supernovae can shine brightest in the blue part of the light spectrum. That specific wavelength is known to mess with our biological clocks by shutting down melatonin production. So imagine, for months on end, a bright blue light in the sky, all night long. It could potentially cause widespread insomnia, mood disorders, and a whole host of other health problems for both animals and us.
All right, so for the main event, the verdict. With these dangers on the table, stripping our ozone and messing with our biology, should we actually be worried about our two main suspects, Eta Carinae and Betelgeuse? Let's start with our first suspect, that volatile giant Eta Carinae. Its distance from us is estimated to be about 7,500 light-years. And that huge distance is, thankfully, our saving grace. A study from back in 2007 pretty much concluded that even if it explodes in a superluminous supernova, which is an especially powerful kind of blast, it's simply too far away to have any serious impact on us.
Phew.
But there's another really crucial reason we're safe. The most powerful radiation from these explosions often gets focused into narrow jets, shooting out from the star's poles. Think of it like a cosmic death ray. And lucky for us, Eta Carinae's axis is tilted away from us. It's aiming its weapons somewhere else in the galaxy. Okay, now for suspect number 2, Betelgeuse. This one is a lot closer, at around 724 light-years away, which, I gotta admit, sounds a little too close for comfort, doesn't it? But here is the number that really truly matters. Scientists have modeled this, and they figure that a supernova like the one Betelgeuse will create would need to be inside about 26 light-years to destroy half our ozone layer. At over 700 light-years away, Betelgeuse is way, way outside that kill zone. We're safe.
So, if we're not in any danger, what will happen when it finally blows? Well, it looks like humanity isn't in for a catastrophe. We're in for what will be, without a doubt, the greatest light show in all of recorded history.
When Betelgeuse finally goes, it will become this intensely bright light in our sky. It'll shine about as bright as a half moon, but all that light will be concentrated into a single, dazzling point. For about a year, you'll be able to see it plain as day, even when the sun is up. And at night, it'll be so bright it will actually cast its own shadows.
And here's the really cool part. We'll know it's coming. See, the very first signals from the explosion, these ghostly particles called neutrinos and ripples in space-time itself, actually travel faster than the light. So our detectors here on Earth will pick them up hours, maybe even a full day, before the star even starts to brighten. The entire planet will get a heads up to go outside and look up.
This incredible spectacle will last for months. Then it will slowly fade away over a few years. And when it's all over, one of the most recognizable patterns in the human sky will be permanently changed. Orion the Hunter will be missing his famous red shoulder, a change that every future generation will see when they look up at the stars.
So while a nearby supernova is a terrifying thought, it looks like our current neighbors are getting ready to give us an amazing show instead of a planetary disaster. It's just a powerful reminder that we live in a dynamic, changing universe where not even the stars last forever. And it really makes you wonder, what other incredible celestial events are just waiting in the wings, just over our cosmic horizon?